What if you're given a graph and you need to find out what the equation is? Here's a graph of an equation. We've learned a ton of stuff about x-intercepts, y-intercepts, horizontal isotopes, and vertical isotopes. Take a look at this graph, analyze it with everything that you've found out, and see if you can come up with an equation that matches this. So go ahead and pause. Take a look at where those isotopes are, both vertical and horizontal, and where your x-intercepts are and your y-intercepts are. Come up with a equation, a formula, and you can name it f of x or r of x or g of x, whatever you would like. And then after you've found that equation, come back and let's check and see if that's what the graph really was. So go ahead and pause and do that. Now that you've gone ahead and found an equation, a couple things that you might have noticed is that you have a vertical isotopes at 1 and -1. Or excuse me, actually these are, a 1 and -1. So if we go ahead and look at it, notice that since they're at 1 and -1, that we have a x squared minus 1 in the bottom. That factors into x plus 1, x minus 1. Now, notice the numerator has a smaller exponent than the denominator. And where is our horizontal isotope? It's at 0. And what makes the numerator 0? That's where you're going to cross the y-axis. And notice there's an x up there. So that makes it so when you plug in 0, you're going to get 0 back. And that's where this crosses the y-axis. So now take a look at this one. See if you can come up with a graph for that one. Now that you've had a chance, let's take a look at it. We have a vertical isotope right here at 2. And notice that that's going to make it so we need a x minus 2 in the denominator. And notice that the graph approaches it from one side here and one side here. That's multiplicity 1. So that x minus 2, you just want to be single. What happens on the other side, though? We have a vertical isotope right here at -1. You would need a denominator of x plus 1 for that. But the graph approaches it from both sides there. So that needed a multiplicity of 2, which means it needed a square there. Now the other thing I noticed is we have a horizontal isotope, and it doesn't look like it's at the x-axis. It's actually shifted up. And notice it is right up here. So since it's right up there, and that looks like that is, we're going up by 1s here, so it's up there at 2. That means that our leading coefficients have to divide and give you a 2. We also cross the y-axis here at 0, 0. So let's go ahead and see if your equation you wrote matches. And this is what was actually graphed. Notice the x cubed makes it so the denominator has a degree 3, and so does the numerator. And our horizontal isotope was at 2, so there's a 2 there. Now, one thing to notice, if it was a -2, we would have been down on the bottom, and things would have shifted around a little. So, but in this case, it's a +2. Let's take a look at one more. Try and find an equation for that. You can pause it. Now that you've had a chance to find an equation, let's take a look at it. We have a vertical isotope right here at 2. So there needs to be an x minus 2. And our multiplicity right here is 2, so that needs to be squared. So now, what about the other side? Over here, we have a vertical asymptote at -4, so that's going to have an x plus 4 in the denominator, and it approaches from different sides. We go down on this side and up at this side, so that just needs a single. And it looks like our horizontal asymptote is at 0. So since our horizontal asymptote is at 0, I'm betting that the top of our fraction has a lower degree than the denominator. And if you look at it, notice that the top only has 2 factors and the bottom has a degree 3. So that means that it's going to go to 0. Now notice I have an x minus 4 there. And I have an x plus 2. X minus 4 is going to be 0 when you hit 4. Look at the graph over here. We cross the x-axis right here at 4. And if I plug 4 into the factor up here, that's going to make 0. So that's where that came from. Notice we cross the x-axis right here at -2. If you plug a -2 into that factor, you're going to get 0. So that's where that factor came from. Now, the 2 in front, that could be just about anything you wanted really at this point. It could be gone or it could be there. It's just going to change how steep things are since the numerator had a lower degree than the denominator. And then the only other thing that you might want to check is down here. It looks like our y-intercept is at -1. So you need to make sure when you plug in 0 for x, you're getting -1 back out. That way it crosses at that point right there. And you can just play with the numbers until you make that happen. And that's how you would determine that you would probably need a 2 out front like we do here. So now we've examined all of the things that we need to examine on our graphs of rationals, and you should be ready to do your homework.